All right. Hey, my name is Rob. Welcome. I'm with Valorum Reply. We're excited to be here today with Microsoft. We partner with Microsoft and innovate with studios to evolve their operating models. And ultimately, we want to get them ready for what's next. But before we start that conversation, we have to acknowledge something. Gaming is not your typical digital product business, but the products that support you often expect you to be. They have licensing models, assumptions, operating playbooks. They're all designed for those typical types of companies. And that's a real disconnect that we want to address today. This isn't about AI hype. It's about real practical solutions. We want to show you that AI can fit inside a real product environment to support creative teams and accelerate workflows. Ultimately, we want to strengthen the economics and operations of your studios. My name is Rob Nelson. I'm a practice leader at Valorum Reply, and we're a Microsoft innovation partner. We help engineering teams integrate AI directly into their existing workflows. Our mission is simple. It's allowing humans and systems to work better together. So let's go back to the gaming studio business. It's important to acknowledge that it's not a typical business. And I've described game studios in the past as operating in an environment of creative chaos, and that's totally a compliment. Studios are filled with artists, designers, and storytellers who also happen to build software. You aren't traditional software companies, and it's time we stop pretending like you are. You work in an environment that's art first. The ratio of artists and developers isn't the same as at a normal digital product business. You work in controlled chaos. And let's be honest, things get slapped together. Not because you don't care, but because you're racing toward a deadline with a creative vision that's constantly in flux. And this dynamic, technical debt isn't a failure, it's a survival mechanism. You work on a CapEx, OpEx roller coaster with massive capital expenditure at the start of a project, and you're forced to predict support costs through a crystal ball. What's the launch going to cost? What is my bug fix tail going to look like? When is it time to reduce infrastructure? These are not easy questions. And then you have a seasonal business model where revenue doesn't flow like a normal SaaS company. After you spike at launch, you ride a wave of planning for the next release. Games as a Service has shifted this model somewhat, but the pattern remains the same. And the ultimate problem is that enterprise tech licensing models assume your consumption is steady state. Support structures expect predictable workloads. We're here because that is changing, and we want you to be part of shaping that future. Before we dive into what that looks like, it's important we acknowledge that there are two really critical pillars of AI. First, starting with your data. Before we even get into that question, though, a lot of people usually ask the question, well, when is the right time for me to start adopting AI? And the answer is never satisfying. It's always one more feature coming next quarter, a newer, better model coming in the next release. The better question is to ask, how will I adopt AI? And with your data, you're looking at things like player behavior, crash reports, telemetry, sentiment, purchases, session data. The question isn't if AI can help analyze your data, it's is your infrastructure ready to feed AI systems that can reason over it? Your tools represent a second critical piece. Every tool in your pipeline, from IDE ticketing, community forums, can be augmented with AI. Not replaced, but augmented. A human stays in the loop, but AI handles the repetitive, the tedious, the impossible to scale. And when you bring these two pillars together, your data flows into AI systems that can reason over data and integrate your tools to take action. And this is what Microsoft calls a frontier company. A frontier company isn't just using AI, it's structured around agentic systems that create, suggest, with humans providing judgment, creativity, and final approval. This isn't science fiction, this is what we're building. And this is what we're going to show you today. But we do need to do a little disambiguation first. There's a lot of preconceived notions about what AI is and isn't. It's important to keep an open mind, but also we put some boundaries around this discussion today. So we're not talking about personal AI. Those are things like grammar summarization, calendar management, maybe even personalized gym coaches, not topics of our discussion. There's also productizable AI, right? Those are features you ship in your games, like NPC companions, procedural generation, dynamic difficulty levels. Also not talking about that today. We're talking about organizational AI, and that's where we're playing. It's to help your organizations operate more effectively and address vast amounts of internal throughput to be more useful. Systems that work across teams, data sources, and workflows. And today we're exclusively going to zero in on organizational AI and the systems that make your studios more effective, more responsive, and more scalable. We're going to cover 4 main scenarios. First, we're going to get started with accelerating gaming infrastructure using AI natural language to stand up the complex Azure infrastructure, moving into an elastic AI support mode that uses Copilot-driven support agents that reduce human escalations at launch. Then we'll transition into agentic bug fixing that leverages AI and creates fixes and runs tests and prepares PRs before they even see an issue. And finally, on to proactive intelligence that moves beyond reactive firefighting to insight-driven decision-making. Hopefully, you can see how these different scenarios fit together. We'll spin up infrastructure, show you how support issues flow through AI to human engineers, demonstrate how by the time the engineer sees the bug, an AI has already proposed a fix, and then pivot from reactive problem solving to proactive opportunity discovery. Everything you're about to see is meant to feel boring, but in the best way possible. And if that feels like something your studio could actually use next quarter, we've done our job. All right, so let's dive in. I'm going to hand things over to our lead infrastructure engineer, Thapa, and he'll take you through our vision of simplifying to scale.
Hey everybody, hope you're having a good afternoon. Hopefully we'll make this session as interactive and exciting as possible. We know that it's taking probably your lunchtime here. My name is Uttapa, so I'm a lead cloud solution architect supporting our Azure customers, some of the largest gaming customers on the Microsoft platform. Today we are talking about essentially how to use AI in terms of managing the gaming infrastructure on Azure. So before we get in there, we wanted to also talk about what's Azure's vision for gaming. Right? Broadly, we can talk about Azure services, products, the AI capabilities into 4 of these buckets. Right? The first one is Studio in the Cloud, essentially enabling end-to-end game creation, whether it is using remote game dev workstations, using GPUs, or using GitHub and GitHub Copilot for source code management, as well as for pipeline management. And then using cloud-native builds and test environments, using low-cost Spot virtual machines, or using low-cost artifact storage using blob storage, right? The second bucket is game hosting. Once you have the games developed, how do you host it? The live services, the live servers, using Azure's geographical span, how can you make these services available with low latency connections to your players? Finally, AI in gaming. How to use AI to assist developers to not just create games, but also, as you will see in the subsequent demos, how to help with player support, proactive management, and then intelligence. And then finally, game analytics. How do you get everything together using a scalable data solution to not to just get real-time analytics of games, but also the developer insights. If you were to project all the services into a workflow, I think this helps to kind of simplify it, right? On the left-hand side, you have a game developer connecting from anywhere in the world to an Azure virtual machine running GPUs, even as latest as RTS 6000, which provides a dual capability of not just graphic compute, but also inferencing. And then you connect to Perforce. You bring your source code management systems, whether it is Perforce or hosted, such as Azure DevOps or GitHub, and then use Azure virtual machines for build farms and test farms, and then use the GPU capabilities to do automated play testing, have all the builds stored in blob storage, artifact storage, and then start using AI for infusion with capabilities that's listed there. Microsoft Foundry is our premier platform, which essentially enables use of models. As of yesterday, I guess we have like 10,000 plus LLMs models in Microsoft Foundry, and also use other AI services such as speech to text, text to speech, content safety in there. And then if you want to train your own models, fine tune them, you have Azure Machine Learning that you can leverage as well. The point here is, if you look at it, everything becomes private, right? Everything is local, essentially, for a game developer, for tester, for builder. It all seems very, with a low latency, a single region or a multi-region connection, it becomes pretty much your own workspace, right? Once you have the game ready for the launch, you have game services and servers that you can span either on Azure virtual machines natively or using container platforms such as Kubernetes. We have an Azure managed Kubernetes platform that you can use for deploying those services and servers as well. And ultimately, Microsoft Fabric, Azure Data Explorer, machine learning, and Power BI for visualization, right? So now you kind of get a sense of the Azure's capabilities for supporting end-to-end game development, right? This slide, in a way, summarizes all the points that we talked about. On the last column, you see different services that are being used for each of those phases of game development. Okay? Yeah, now that you have a sense of what's in the workflow and how you want to use, or rather what services to use, how do you want to use it, right? It's not always easier to adopt a new platform, like a new cloud provider, right? So that's when we wanted to start thinking about a vision of how can we use AI to essentially use natural language and then spin up infrastructure that we need instead of learning the primitives of Azure platform. If some of you probably have looked into Azure, so you need a subscription, you need a resource group, you need to create different resources, and they all come together to for example, create a game development workstation. So how do we make use of natural language to get to that stage? Probably in the matter of few minutes to an hour, right? So that's the goal here, and that's what we wanted to present to you. So what you're seeing is a UI that we built on top of Azure. It essentially enables some of the capabilities that we talked about using AI to launch 4 important components within that workflow that you saw. One is the game development workstations, build test environments, automated play testing, as well as the game server hosting, okay? So we'll see how it all comes together. If I head on to AI Assistant, so there is this general chat option, right? This is an unauthenticated, you don't need to have any access to Azure environment, just to ask, for example, simple questions like, how do I get started with game development on Azure, okay? This essentially gives you a different step-by-step requirements on how to get started on Azure for creating a game on Azure, right? You can go a little more detail and ask, what are some of the best virtual machines that are available on Azure for GPU-based game development? And then as you can see, you didn't have to specify the VM SKU or the GPU type. It actually provided you some of the options that you can use on Azure today. I can go a little more trivial in here, right? Give me most cost-efficient machine for 2 vCPUs and 4 GB of memory near San Francisco, right? So it found the closest Azure region, and then provided you an option of different virtual machines that you can use for example, say, build test environments, okay? And then if you wanted to just find cost, okay, the cost is an important aspect. So what does it cost to run 50 virtual machines with T4 GPUs near Phoenix, right? And it converted that intent into context and then recognized what you would probably need and then gave you some insights on how to get started on Azure. Okay? Now I'm moving to Game Dev Agent. This is an authenticated, context-aware agent, right? It knows that you are logged into an Azure portal, you have access to an Azure subscription. Now all the next set of chats are context-aware and tied to that user and subscription. So here is an example. I'm just telling, create 3 game development workstations with latest NVIDIA GPUs and have Unity Engine Visual Studio Code in East US, right? So if you can see here a little more into the thinking of what's been happening in the background, it resolved to the closest region. And then it actually selected the GPU and the workstation that would match your requirement. And then it actually does the quota check. Do you have enough vCPUs in your subscription to create those, right? And then ultimately it queued the software that you would install, and then it applied the latest GPU drivers that are required to run on that virtual machine. And then finally, it gives you an option for a human loop to actually review what what you asked for, and then the response that you got to say, okay, does it all look good? And then you approve for creation of it. As you can see, it's not automatically creating something, it's giving you templates and options, and so that you do the final review and then essentially deploy it on Azure. Okay? Let's do a live demo. So I'm going to AI-assisted agent, and I'm going to demo a game server scenario, right? Here is a scenario. Set up a battle royale game for 1,000 players across US, Asia, and Europe in Arizona, Japan, and Stockholm. I'm specifying a state, a country, and a city, right? To see if it can essentially transcribe that intent into a context-aware deployment. If you see what it did here, it selected the region closest to Stockholm, Sweden Central, US West 3, near Phoenix, and Japan West. And then it selected a common virtual machine type for hosting game servers. It did the live quota check, and then it also found that the VM scale set, which is an Azure offer to create these scale sets in or virtual machines in a scalable manner. And then ultimately, it's asking me, okay, tell me what project you want to deploy this for. I select a project, and then I say deploy now. So if I head back into the game server tab and the deployments, and then if I do a refresh, so now it has that option created for me to review and provision. And we can review the requirements that we specified to see if it matches what we really selected. We selected the project, the virtual machines, the subscription, the deployment name. It actually creates a resource group. If you know Azure primitives, this is the container where it creates the resources. And then it automatically selected and does the pre-check for all the quotas that you have to run in those 3 regions that we talked about. It also asks for specific TCP ports and UDP ports that you want to open where the games are actually exposed. And then ultimately, you would want to have a public IP enabled for each of the nodes so that the player sessions can be enabled. And then you can either upload your game executable, container image, or choose a sample server that's shipped with this. And then I choose next. It creates ARM templates, Terraform templates, so that you can use it for subsequent deployments. And then as you do this, parallelly, it does the cost estimation as well for the compute option that you selected. And then I say, okay, everything looks good. Now go and deploy, right? So now, in the background, it's doing that check again. Do you have enough quotas? Do you have access to the subscription? Do you have enough capabilities that's enabled on that subscription to do this? And if I head back to the Azure portal here, you can already see that resource group being created. And then we didn't have to worry about network security group, virtual network, anything that's related to Azure, right? So it's actually creating those services in the background. Now you can see, all the required capabilities are now created on Azure portal without you having to specify any of them. Then if I head back on the visualization tab, you would actually see that project being also available. And then we added some capabilities into the UI to actually check for the health of those virtual machines as they are created. So you don't have to go back to the Azure portal and check. So it's actually getting the live intelligence back into this console to see, okay, how many players are connected, to what are the public IP addresses, and what are the health of the virtual machines in here. Right? So as you can see, within a matter of few minutes, of course, with some setup in the background, you as a developer, a studio administrator, can actually spin up the infrastructure pretty quickly without having to really create a platform of your own, right, using natural language. So that's what we believe the power of AI is, right? How do we make you more accessible to a technology that probably would have taken a few hours to a week to get there, right? Yeah, and we definitely would like your feedback and then see, where to take this, to the next level. And then I'll hand over to Mithuna for, demonstration of some capabilities after the launch. Thank you.
Thank you, Uttapa. I'm actually going to stand up so people can actually see me. Firstly, thank you for taking the time to come and attend this session and learn about some of the solutions that we are building. I'm Mithuna Srinivasan. I'm a practice lead for applications at Velorum Reply. Now that we've seen how infrastructure can be spun up on Azure for games to be deployed for a variety of audience and platforms, let's switch over to a scenario where our game devs, engineers are actually trying to release a bunch of new features for a game across various platforms. We've all been there, done that. Teams have been working diligently for weeks on several features, working on testing all of these scenarios, edge cases, different use cases. And no matter how hard we try, when it comes to launch day, there's always bound to be some issues which arise. So what we're going to talk about next is a multi-tiered support system that we have built using Azure Foundry. Actually, to the slides, sorry. Sorry about that. So this is a multi-tiered agentic system which emulates real-world support scenarios. So in any organization, we have these tiered support systems, like an L1 system, which is really the first line of support, right? Like an agent or a human in the loop answering questions from users, really trying to acknowledge the issues that these users are facing and provide them like the next steps to follow up. And then you have a tier 2 system or a tier 2 agent, which is really what we as engineers do, right? Like fix a bug, release the patch, and make sure that the issue is closed. And tier 3, again, would be the human engineer for a higher level of escalation. The tier 1 agent really is a chat interface which is grounded in information which is available to the system. It could be FAQs, forums, wiki, release notes, basically all of the information which is available about the system. And if a user comes in, the system is able to answer questions based upon its repertoire of data. Now let's see how an issue flows through this multi-tiered agentic system. I'm going to step over to the desk so I could do a quick demo. All right, thank you, Rob. So here's a quick site that we have built to showcase these multiple agents working together. You're all free to launch the site and try it out and play a game of asteroids while you're at it. But imagine an end user coming in and having to look through like reams of information like FAQs, wiki, forums, etc., to figure out what's going on. But they also have this agent which is available to them, and they could interact with it in a natural language, trying to figure out what's going on. So here I have like a pre-canned text that I have already copied. So I'm going to paste it over here into the agent. So every time with the new release, version 1.2.3, the game crashes when I try to launch it from the Xbox Marketplace, and I'm using an Xbox Series X. So as a user, when I type this in, the agent immediately acknowledges the issue and starts working within his knowledge base to figure out, like, hey, is this an issue that I've already seen before? Can I find like a resolution within the FAQs or wiki or forum somewhere and hand it back to the user? So here you can see that our tier 1 support agent has looked through all of the documentation that we have and is presenting a resolution to the user. The user tries all of this, have done multiple things, it's still not working. So let me say that still need help. So at this point of time, the agent then acknowledges that, hey, this is not something that I've seen before. This is not something that I can solve for. So perhaps it's time to escalate to the tier 2 agent, which performs a much more deeper analysis. So the tier 1 agent acknowledges the user over here, like you can see, and then asks the user to enter a test email so that they could follow up with the user. So the whole idea behind this agent is to really provide that acknowledgement, interact with the user so that the user does not have to scramble around to figure out the information. It's more of a natural conversation where users can provide support logs, provide any crash dumps, and so on and so forth. Now, the tier 1 agent, what it's also doing in the background is then handing off to the tier 2 support, which is, again, an agentic workflow which kicks off. Rob, I'm going to have you switch over to the slide. So the tier 2 agent basically looks at all of the support tickets which are being submitted by the tier 1 agent, tries to find patterns because there could be thousands of users who are logging the same issue from the same device using the same kind of input metadata. So the tier 2 agent really kicks off and says like, hey, there are multiple people reporting these issues. So perhaps I should consolidate all of that information and treat it as one case, attach all of the crash dumps and logs to it, and then log one single ticket so that the development team is not burdened with looking at multiple issues, triaging all of these issues, trying to form a correlation between them. Because every minute the engineering team is spending on triaging issues is a minute they're spending away from actually solving the problem. So here's a sequential set of steps that the agent 2 does. So it detects what the issue is, creates this bug, makes sure that the team is notified that there's a bug which has been identified, reported, let's say, 2,500 times. All of those crash dumps, et cetera, associated in the same bug, automatically created within ADO, as an example. Now, is this where the life cycle of the tier 2 agent ends? Not at all. It just doesn't create the support ticket and then, say, I'm done. So what we have done is we have taken this a step further. So the tier 2 agent also has access to our source repository, our code. So the tier 2 agent is able to perform an analysis of the code, identify where the issue lies, and suggest a fix. Now that it knows what the fix could be, the agent is next able to generate a fix, create a branch, create a PR, and also spin up a test farm to run unit tests, not existing ones, but new ones, which are applicable to this particular scenario, to this particular cohort of users on Xbox and when they launch version 1.2.3 on the platform and so on and so forth. Able to run the test cases, run through it immediately, and then create a PR, which is then ready for the human in the loop or the human review. So let's take a quick look at a demo of what this would look like. So I'm going to sign into ADO real quick. So you can see that there is a PR which is ready and has been created for the team to come in and review. Now that you've seen the various steps, let's actually look at what the tier 2 agent did. So the tier 2 agent actually created a bug first with all of the report and the details created under it, the crash dumps associated with it so that all of the users have that for analysis. So you can see the associated work item over here. Next, the agent was able to kick off and say like, hey, I think this is a defensive fix which needs to be added. This is potentially where the solve could be for this particular issue. I recommend changing this particular line. And I have a confidence that once this fix is applied, it's going to be about X percentage, it'll solve the issue. So once that is done, the agent is also able to spin up a test farm to run unit tests, validate them, and generate a report to say whether this unit test passed or it failed. So here you can see that it's put in a comment which says that, hey, I ran these unit tests and all 428 tests were green, integration tests, load tests, and also the platform tests for that particular platform for that particular scenario, and say that, hey, did this particular thing pass? And here are some of the issue-specific tests as well that it was able to spin up and run. And you can see the code coverage percentage, which is, again, generated by the AI. The next step in this sequential process is for the agent to also kick off a senior engineer perspective, put on the hat of a senior engineer and look at it and say like, hey, is there anything that can be done to make this code even better. And you can see that the agent took that input, reacted to it, made the fix, and submitted another update. And now it's finally ready for the human in the loop for a review. So what this whole scenario does is, it reduces the amount of burden that is placed on the engineering team to look through a host of these issues, triage them, then decide what the fix is going to be, how do I design this, how do I test this out, and how do I then put it in front of the users. So basically, the issue is already logged. There is a PR. But again, it's very, very important to have the human in the loop to review the design, to review the fix, to make sure that this is absolutely right, and we have to, then make the release. So what I'm going to do over here is, this looks good to me, so I'm just going to say approve, and I'm going to complete the PR as well. And this is going to kick off, completing the PR, of course, and then kicking off a build so that this could be released onto the site. Now let's go back to our support site and see if this version was deployed. There it goes. So we have a new release, version 1.2.4, which is available now for users. The users are notified as well because they have provided their email IDs. So there's a quick follow-up on that. And then, you also have the wiki, which has all of the notes, the patch notes, the release version is updated over here. So all of this, again, is available as grounding data for our tier 1 agent as well. So now if a user reports the same issue, it essentially kicks off the tier 1 agent, which is your first line of defense again, and then it can bring up the issue and say, like, hey, this has been sorted, so try updating to version 1.2.4, and you'll see that the release is done. So with that, a really end-to-end system which can emulate a real-world L1, L2 scenario, and really help engineers focus on solving the problems rather than having to do repetitive tasks like, hey, I'm going to log a bug and I'm going to triage the bugs and so on and so forth. Thank you, and I'm going to hand it back to Rob.
Awesome. That was great. So thanks, Mithuna. Everything we've shown you so far has been reactive, right? So a player reports a bug, a crash appears in telemetry, something goes wrong, and AI helps you respond faster. Great. But what if we could get ahead of problems? This is where we shift from reactive operations to proactive intelligence. The problem is we have more data than we know what to do with. Telemetry, user behavior, purchase patterns, feedback, session data, A/B test results. Until now, making sense of this requires analysts, it requires time, and even more critical, a hypothesis. And that's where we run into even bigger problems because humans bring preconceived notions to the table. We look for what we expect to find. We test ideas that seem reasonable, but we all suffer from the same universal human condition, confirmation bias. What if you could get ahead of things and look for things you never thought you could look for? So I'm going to hand it back over to Mithuna, who's going to show us something incredibly powerful we've put together using AI to uncover new opportunities in your business and identify the next best action.
So the next demo that we're going to talk about is the agentic gaming intelligence foundry. So it's really a platform that we have built, which is an AI-driven platform built on top of Azure Foundry, and it uses Fabric as the data source. So this platform basically has the ability to look at data across several gaming portfolios in a particular game studio and able to reason over the data. Now, when we are talking about, earlier we were talking about data and AI and tools in AI, this solution actually embodies both of those areas. So let's dig in a little bit deeper into what the agentic gaming intelligence foundry is and what it does. Now, like I said, the data is all based on Foundry. It's based on Azure Foundry, and the data is all stored on Fabric. So this could be data from various kinds of sources, right? Like structured data or unstructured data. So you could have data like session data, user sentiment analysis, in-game telemetry. It could be social media posts or forums, information, purchase history, retention data. So multitude, different kinds of data, which could really be in Fabric. And you have this agentic multi-agent framework, which can reason over it and generate insights based on the end user's goal. In this case, it's a business user. So in this tool, as a business user, I have the ability to set an objective for myself. So in my case, you can see over here that my current objective is to increase revenue across my portfolio by 35%. So any insights that the agent is able to glean from the data is all centered around this particular objective. Now, getting back to the tool, there are different modalities by which I could interrogate the data. Let's look at scenario 1, wherein I'm really using the chat interface to talk to the agent and figure out, like, hey, is there any specific insights that I could draw? So there are a set of pre-canned prompts that I could use, or I could type in my own. I'm going to just use the Dow trends because that is relevant to me. So let me just say, show me the Dow trends for all of the games in this portfolio. Now, what's really happening here is the multi-agent framework kicking off. At first, you have the orchestrator, which is trying to understand, hey, what is this question that the user is asking? What's relevant? Which agents should I engage with? So in this particular scenario, like you can see, the orchestrator then engages with both the SQL agent and the Fabric agent, to query the data and then to fetch the relevant data and generate an insight which is applicable to me, centered around my earlier objective of, hey, increase the revenue. So let's give it a minute to actually work on the data and generate an insight, which we could then dig into a little bit more. And again, like all of these agents are really working, they're real data agents working on real data. When real data, we mean synthetic data, and this is not like actually data from game studios. So this is really half of the experiment because we are working with synthetic data. So in this scenario, so you can see that it generated an insight, which is basically at a cross section of like data from like user sessions, telemetry, et cetera. And then you see that, hey, there's this particular insight that I was able to draw from it. You can save this insight and generate like visualizations around it and really act upon it based on the suggestions. And the confidence level is like pretty high for this particular insight. Now, this is a scenario when you know what you want to query on top of the data that you have. What if I don't really know and I want the AI to run unbiased on all of the data as and when the data is updated across Fabric every single day? That's when I switch over to the Insights portion of the tab. And I do apologize for the bug that you see over there. We'll make a fix for it. But essentially, the agents here are really running across and looking at all of the data in the system and trying to generate insights relevant to me and my portfolio of games based on my objective again, and stack ranking them based on actions that it thinks we should be taking. Now, each of these insights come with a recommended next best action, a confidence level, which clearly needs to be fixed over here, and the expected impact on taking the next recommended action. Now, what's interesting over here is also this test hypothesis, which is basically an agent that I can spin up, which is a hypothesis agent, which then, I'm going to quickly spin that up so I can show you a demo of that, which can run this hypothesis against a certain test group, a certain statistical threshold that the agent is able to determine, and run this for that particular user cohort for a certain period of time, let's say 3 days over here, and also monitor the results to see what the impact of this hypothesis could be. Now, this is something that you wouldn't naturally look to see there, but with all of these agents working together, generating like an insight and then generating a hypothesis that you could run, really experiment with, monitor the results, and then potentially extend it to the entire user base if the hypothesis holds, is a powerful tool. So imagine if you have other tools within your portfolio. So let's say there was a tool which could send emails out to users. And let's say there is another tool which could generate like a buy one, get one off offer, right? Like for particular games. So the hypothesis agent is basically building an agent on top of your existing tools, where it could then engage with these tools and then say like, hey, I'm going to run this particular hypothesis and let's send out a buy one, get one off offer for like 10% of your users at this particular time. Let's run this hypothesis, monitor the results for like X amount of time, and see what the consequences are for that, and then use that information to actually expand it out to our entire user base. So this really gives more meaning to the data, generates insights around the data, and really showcases what we can do with these agentic capabilities. With that, I'm going to hand it over to Rob to wrap up the session.
Great, thanks again, Mithuna. All right, well, agentic gaming intelligence foundry is our way to let AI identify new threads to pull on. We run experiments to see if they go anywhere, and we enable people to cover more ground discovering new ways to improve the business. It's about moving from data-rich, insight-poor, to data-driven decision augmentation. You'll find things you didn't know you were missing, and test, validate insights all at once, at scale, with AI doing the heavy lifting. It's important now that we can stay focused on looking ahead and not fighting fires. This isn't about dashboards, it's not about alerts. It's about real-time understanding of what's happening in your digital experience across players and systems and teams. It's truly organizational AI working the way that studios actually work, at the pace that you guys demand. So, real quick, let's kind of recap what we saw today. We saw infrastructure with intent. You describe what you want, and AI builds it. We saw support that scales. AI handles volume, humans handle unique problems. And we saw fixes before engineers arrive. By the time you see a bug, it's already been solved. And then finally, with proactive intelligence, we move from firefighting into opportunity finding. This is the Frontier Company and the Frontier Game Studio. This is what's possible when you combine data, your tools, and AI with strategic intent. We aim to free up your creative talents to focus on what you guys do best. We aren't just here to demo. Microsoft is seeking game studio partners that are willing to deploy solutions like this in your organizations. As part of that partnership, you'll get full deployment support from Valorum Reply, Microsoft's partner in this initiative, early access to these AI capabilities, direct input into how these solutions evolve, and a voice in how Microsoft shapes offerings for the gaming industry. What we ask is your willingness to deploy and use these solutions in real scenarios, and permission to share learnings from our work together with Microsoft, of course, only what you approve, and your honest feedback about what works and what doesn't. Like we discussed, this is the beginning of gaming, and gaming and operations, and it doesn't act like a typical technology company. This is your chance to shape the future of a solution made just for you. This is not about AI so much as about defining what AI in gaming really is going to look like. So you can find us after the session, and we'll be happy to go deeper with you. We're available for one-on-one conversations where we can discuss how we'll help your studio. So thanks for your time today.